This is the presentation for the vertical slimline twin-cylinder steam engine. I'm Jacob Adamski.
My name is Liqiang Chen.
Alright, so for our overview, we're going to start off by going over the team dynamics, which is basically how we split up our parts and how everything came together. Then we'll go over the main assembly, which will lead us into explaining the sub-assemblies and the parts that comprise those assemblies. And then we'll go into explaining critical parts, which are basically parts that gave us a little bit of trouble. There's not that many because this is a pretty simple project, but there are some nonetheless. And then a few final remarks in the conclusion. Okay, team dynamics. So for the most part, work was completed individually. We didn't really ever meet together until we actually had to write the report and record this video. The way we split up the parts were by location in regards to each other. So parts that were close together would be assigned to one person, and likewise for the other person, so that when they are put together in the assembly that they would match up, or at least that would be easier to match up. I don't know if it actually made it any easier in theory, but that's how we did it. We didn't really create any schedules. We pretty much did just everything on our own pace because, like I said, this is a simple project, so I think we had plenty of time to complete everything. Now, my responsibilities were the left hand and right hand mainframe port blocks, the piston rod crank, the reverser, steam pipe, cylinder restrainer bracket, the reverser spring, and the spring. And I also did the exploded and assembled view drawings for the main and sub-assemblies. And I also did some, I believe, some nuts and bolts too that I didn't list in there because they're not actually listed anywhere in our drawings or assemblies because they're just unimportant repeated parts.
So I did the flywheel housing, the flywheels, the crankshaft bearing, the crankshaft crank plate plus the pin, the cylinder top, and the bottom lids. I also did the base tender and some screws and nuts. I also did the entire sub-assemblies and the main assembly. So we start with the main assembly. I divide the main assembly to 5 sub-assemblies. The reason I divide it to so many sub-assemblies is I want to keep the sub-assemblies simple. So more sub-assemblies means less parts in each sub-assembly, which lead to less constraints and makes the sub-assembly easy to create and modify. So those 5 sub-assemblies were connected by screws and nuts and springs. There's only 4 constraint types I used, which are coincidence, contact, offset, and angle. So here is a exploded view for the main assembly. From top to bottom, you can see there's 5 sub-assemblies. The one on the top is the top sub-assembly, followed by the flywheel, the base sub-assembly, and the 2 sub-assemblies on the side are the cylinder sub-assembly and the arm. You can notice here the cylinder sub-assembly and the arm sub-assembly were copied twice, because it's how it lands up on the main sub-assembly.
Okay, so the arm sub-assembly. This is only 3 parts, and actually in reality on the original PDF that we had to model this from, this was just one single part, but I split it up into 3 parts because it would just make sense because it looks like it's 3 different parts. These are glued together. Basically there's no screws or bolts connecting them. And yeah, as you can see, it's made up of 3 parts. At the top you have your piston rod crank top, and then your piston rod crank rod, and your piston rod crank bottom. There's really no twists or turns to this little assembly.
So here is a cylinder sub-assembly. Although the graph on the right looks complicated, but it's really only 3 parts in this sub-assembly. Like I said, I divide the main assembly to 5 sub-assemblies, so each sub-assembly contains less parts. So these 3 parts are connected by the screws, as you can see here. The part on the in the center is the cylinder, and the part behind the cylinder, I believe, is the top lid, cylinder top lid, and the parts from the cylinder is the cylinder bottom lid, and there's 8 screws to connect these lids to the cylinder. And here is the flywheel sub-assembly. There's also 3 parts in this sub-assembly, and they are glued together since there's no screws connect each other, connect parts. And here is the exploded view for the flywheel sub-assembly. So number 1 is the main part, the flywheel, and number 2 is the crankshaft, and the number 3 is the crank plane plus the pin. And here is the Bolden sub-assembly. It's really the most easy, most simple sub-assembly in this project. Also, there's only 3 parts in this sub-assembly and connected by the screws. As you can see, those 3 parts on the base, which is basically a cube, and the flywheel housing, which holds the flywheel, and the crankshaft bearing.
So unlike the cylinder subassembly, this subassembly, the top subassembly, is as complicated as it looks. It has 5 main parts and it's connected by screws and springs, and yeah. So let me go into what it's comprised of. So this is the exploded view. It's a little bit messy, but starting from the number 1 part, so you have your cylinder restrainer bracket, which holds together your left hand and right hand mainframe and port blocks. And then you have your reverser arm, disc, and rod. Now this is actually also like the arm subassembly. This is 1 part, but I split it up into 3 parts because it also just seemed to make sense to do that. And then you have your steam pipe, your reverser spring, M5 washer, M5 nut, and then you have some nuts and screws on the outside, which I don't really need to point out. Now, critical parts, as I said before, these are parts that just gave us a lot of trouble. There aren't that many. There's only 2, the cylinder and the left-hand mainframe port and block. But yeah, they gave us trouble, so we'll explain why.
So the first part I want to mention is the cylinder. So at the beginning, when I look at the dimensions of the cylinder, it's kind of complex because it takes me some time to figure out how the overall shape actually looks like. But once I figure out the dimensions, it actually kind of easy to create the overall shape. But when I create the, as you can see, the top rod and the bottom rod of the part, since there is a circular pocket on the center, there's no surface I can actually create the sketch to create these 2 rods. So I end up to create 2 extra play using the play tool. And the reason I point this part out is because this is the only part I use the plane tool in order to create the surface for sketches. All the other part is kind of easy. I don't need this to create an extra plane to finish those parts.
Alright, the left-hand mainframe and port block. So this part, I guess you could say it is just a flat plate. However, there's a lot more going on and a lot of reasons why this part was difficult to model. Now, first of all, it's kind of got a lot going on the inside. You have 2 channels here which don't go all the way through and a bunch of holes just scattered all over the place in seemingly random places. Now, on the PDF file that I modeled this from, it was kind of hard to get the overall shape of the plate itself because on the top here it was split up so that it was 20 on the top, but then also by the radius here. And those 2 dimensions actually were conflicting, so I had to sort of just make a guess because those conflicting dimensions, my theory is that they were actually estimated, and one of them is less than the other, but I have no idea. so I just went with my gut on that one. Furthermore, these holes, these 4 holes here, are, I guess, lined up by pitch circle, which is listed here, which isn't showing on this drawing for whatever reason. Originally, I thought these holes were tangent with the top and bottom of the circle, but in reality, these holes are lined up on the diameter of the circle, which is, of course, like I said, you can't see because it's not showing on this drawing for a different reason, but that one caused me to have to redo this model a second time to actually get it right. But overall, I was able to complete it eventually. So in conclusion, it was a pretty simple project aside from those last 2 parts. I mean, everything went pretty smoothly and simply. Our greatest strength as a group was the fact that we completed the parts and drawings early enough that we could do this presentation and the report without being pressed for time and being too close to the due date. In future and for more complicated projects, we should probably make some sort of a formal time schedule so that we can actually figure out when things are going to be done, and that way we can definitely get done early enough, but wasn't necessarily this time around, so that's our project.